Welcome back to continue chapter 8. So today we're going to focus on graphing these rational expressions. So we're going to start with something called the reciprocal function family. This is the most basic of the rational functions. And the neat thing is, graphing these is basically just those set of transformations that you learned before. Today, before we cover transformations, though, we just want to cover the very basics of what these reciprocal functions look like. So when I say reciprocal function, what I'm talking about is I'm talking about something in this form. Y equals A divided by X. Now, yesterday you kept seeing K, which works as well. But when we're talking about graphing, they use A because this is going to be the vertical stretch. Remember in all those examples, we've done a transformations before, they use an A to represent the vertical stretch. Well, that's why they've transitioned using A. Again, if you really think about it, A is going to be the same thing as the K that we were just using in the last section. Oh, I apologize for that. So, some things I want you to notice, all right? Some pointers. There are two asymptotes. Now remember, what asymptote means is a line that the graph is approaching forever. And these things have two of them. Notice there's a vertical one at 0 and a horizontal one at 0. We have two asymptotes for every one of these rational or of these reciprocal functions. Also notice because of that, that also means that this most basic form of the reciprocal function doesn't have any x or y intercept. It doesn't ever touch the x or y intercepts. The domain and range are both all real numbers except where an asymptote is. So for these most basic ones, that means the range and domain are all real numbers except 0. And the last thing I want you to notice, there's two branches for each of these reciprocal functions. If A is positive, then they're going to be in quadrants 1 and 3, like this one's shown right here. Quadrants 1 and 3 are where your graph exists. If A is a negative number, then it'll exist in 2 and 4. So it would exist over here instead. All right. So just a few little pointers before we get started. Now, again, those are just kind of the minor details. The big picture is, are you able to create a graph to represent these? So let's get started with this idea of graphing. Excuse me. So we're going to make tables based on the parent functions. We're going to use numbers that divide evenly into A. All right, so when we're choosing our numbers, graphing gets a whole lot easier if you choose strategic numbers, okay? So I know that I'm going to be using my x to divide 8. So it would be convenient if I choose values that evenly divide 8. So what I mean by that is I'm going to start with 0, and then 1 divides 8. So I'm going to use 1 and negative 1. 2 divides 8. 4 divides 8. And 8 divides 8. Now this may look like a lot of points, but keep in mind, if all we're doing is quick dividing, those points are really easy to get. All right? So I'm going to start at that 0 point. Because 8 divided by 0, I can't do that. That's why I'm getting that asymptote there. So at 0, it is undefined. Again, I can't divide there. It doesn't work. That's why I get an asymptote. 8 divided by 1 is 8, and 8 divided by negative 1 is negative 8. 8 divided by 2 is 4. 8 divided by negative 2 is negative 4. 8 divided by 4 is 2, and 8 divided by negative 4 is negative 2. 8 divided by 8 is 1. 8 divided by negative 8 is negative 1. So notice again, pretty easy to make that table as long as you choose strategic values. And by strategic values, again, we're talking about things that divide that number. Now, before I even get started, it's convenient if I put my asymptotes right away, okay? Because that'll show me where my graph is approaching. So I'm going to put both asymptotes on before I even start plotting points. I put those on. And now all I have to do is plot those points. So I have, let's see here, I have 1, 8. I have, oh, I'm sorry, started in the wrong place. So I have -8, -1, -4, -2, -2, -4, -1, -8. Then I have 1, 8, 2, 4, 4, 2, and 8, 1. So notice I'm getting my 2 branches. So all you have to do is connect both of them to get your points or to get your curve. All right, now, just to re-emphasize some of these points. So for the domain, again, domain, all real numbers except where that asymptote is. So it's all real numbers except the fact that x can't be 0. Same thing for the range. The range is all real numbers because we don't want to let y be 0. So that's the thing about these rational functions. They exist everywhere except where you have an asymptote. Vertical asymptote, well, we already said that's where x is 0. Horizontal, where y is 0. Then both x and y intercepts, in this case there aren't any, because with the asymptotes on the axes, they're never going to touch either of the axes. And that's going to be true for all of these reciprocal functions today. All right? The domains are going to be all real numbers except 0. Both asymptotes are at 0. And because of that, there won't be x or y intercepts. All right, looking at this next one to graph it. So again, we want to choose x and y values that are convenient. So I'm going to start at 0. And what are some numbers that conveniently divide 12? Well, -1 or 1 and -1 do. 2, 3, 4, 6, -2, -3, -4, -6. Again, I'm just listing numbers that divide 12. So, it's undefined at 0. Again, we can't divide by 0. Now, -12 divided by 1 is going to stay -12, but -12 divided by -1, negative divided by negative, will become positive. -12 divided by 2 will give me a -6, but when divided by -2, it'll give me a +6. When divided by 3, it'll give me -4. When divided by -3, it will give me a +4. Divided by 4 will give me a -3. Divided by -4 will give me a +3. Divided by 6 will be a -2. Divided by -6 will give me a +2. All right, so I have all of my values. So now I'm going to start plotting them. But again, before I start plotting them, I am going to quickly put my 2 asymptotes. Okay? For these basic ones, again, they will always start at 0. Now 112 or negative 112 and 1 negative 12 are both off my chart. So I'm not going to plot either one of those because again, they're sitting off. So I'm going to do the negative 6 first. So negative 6, 2, puts me right there. Negative 4, 3. Negative 2, 6. And then negative 112 again is off my chart. So I'm going to jump to 2, 6. Oh, I'm sorry, I forgot one right there. And I put that in the wrong quadrant. It should be 2, negative 6, 3, negative 4, 4, negative 3, 6, negative 2. So notice, just like I said, when that A is negative, because we have a negative value there this time, notice it shifted where those branches are to my graph. Okay, now the branches are on quadrants 2 and 4 instead. And I want you to notice domain and range. Again, the domain, I can use any number except I can't use an x equals 0 because that would make me divide by 0. The range ends up doing the same thing. Again, the range is everywhere except that asymptote. And the asymptote is at y equals 0. And again, my two asymptotes, well, they're sitting at the zeros. That's where today they're going to sit until tomorrow when we start shifting them around. And then x-intercept and y-intercept, there aren't any because, again, if they can't touch the axes, they're not going to have any intercepts. All right. So let's keep moving. Now, to show you some of these, what the stretches look like, we're going to whip out our calculators. Now, in a couple days here, our calculators are going to be extremely, extremely important. So I want to show you how to do these on the calculator. So I want you to whip out your graphing calculators, please. And we are going to graph 3 of these. All right? So to graph, we need to go into our y equals. Now, if we're doing 3 graphs, I'm going to be using 3 different lines of these because I want to superimpose those graphs on top of each other. So the first one, 6 divided by x. We want to see what that looks like. And we want to compare that to 0.25 divided by x and compare it to negative 6 divided by x. So let's graph these and see what they look like. So these are what those 3 graphs look like. And so again, I want you to pay attention to what happens. I want you to notice that red line is at 0.25. So that's a vertical compression. It's pulling it, it's shrinking it. The blue is that 6. So that's why that one's so much taller. It's being stretched out vertically. The black one represents the negative 6. So notice that negative shifts the quadrants that it exists in. All right, so again, just a really quick thing to show you how these stretches and reflections work in terms of these reciprocal functions. All right, so or do the asymptotes change? No. Stretches cannot change the asymptotes. Stretches also don't change the intercepts and don't change the domain and range. That's why everything today has been consistent, because stretches and compressions aren't going to change those. Those won't start changing until tomorrow when we do all of the other, the translations. So before we finish, I want to do one word problem with you. So the rowing club is renting a 57-passenger bus for a day trip. The cost of the bus is $750. 5 passengers will be chaperones. If the students who attend share the cost equally, what function models the cost per student C with respect to the number of students N who attend? What is the domain of this function? And how many students must ride the bus to make the cost per student no more than $20? All right, so looking at this. So first of all, we need to determine how many or what the equation is. So cost per student. So what is it costing per student? Because it's saying that the students are equally sharing this cost, not the chaperones. The chaperones get to go for free. So that's $750. So that $750 is going to be evenly distributed through or to those N kids. All right. So now it wants the domain of this function. Now the domain is coming from the fact there's 57 passengers, right? Just 57 passengers, but 5 of those spots are taken by chaperones, okay? So if 5 of those spots are taken by chaperones, that leaves room for up to 52 kids. So that means we're going to have from 1 up to 52 students. Right? Because again, if there's 5 chaperones going, that only leaves 52 spots for the kids. So that answers the piece about my domain. Now I want to answer the piece of how many students must go so the cost per student is no more than $20. So I'm going to put $20 in for the cost. We want to see how many kids will have to go. Well, to solve this, you've seen this a couple times now, how to solve something like this. The first thing you want to do is get your variable out of the denominator. So I'm going to multiply that n over. Well, now n clearly still isn't quite by itself. So I'm going to divide 20 over to the other side. So 750 divided by 20 is 37.5. So what that means is I need at least 38 students, because we're not going to have half of a student, so we're going to have to round. So I need at least 38 students in order for them to pay no more than $20. All right, thank you for joining me for this. So I want to make sure you have all this written down and then come back prepared to do your practice work in class tomorrow.